Welcome to this video on encryption and decryption, where we'll explore how data is secured and protected in the digital world. This is an essential concept in computer security that affects everything we do online, from sending messages to making online purchases. Encryption is the process of converting readable data, which we call plaintext, into an unreadable format known as ciphertext. This transformation protects the data from unauthorized access. Think of it like putting your information into a locked box that only certain people can open. The original readable message goes through an encryption process and becomes scrambled text that looks like random characters to anyone who doesn't have the key to unlock it. Decryption is the reverse process of encryption. It converts the encrypted data, or ciphertext, back into its original readable format, which is the plaintext. This is done using a special decryption key. To continue our locked box analogy, decryption is like using the correct key to unlock the box and retrieve your original message. Only authorized parties who possess the correct decryption key can convert the scrambled data back into its original, understandable form. Encryption relies on keys, which are like digital passwords that control the encryption and decryption process. There are two main types of encryption keys. Symmetric key encryption uses the same key for both encrypting and decrypting data. It's like having one key that both locks and unlocks a door. Asymmetric key encryption, on the other hand, uses two different keys: a public key for encryption and a private key for decryption. The public key can be shared with anyone, while the private key must be kept secret. Let's look at a practical example of symmetric encryption. Imagine you want to send the message, "Hello World." First, you use a symmetric key, let's say ABC123, to encrypt the plaintext. This encryption process transforms "Hello World" into ciphertext that looks like X7#MK9 at sign PL2. When the recipient receives this encrypted message, they use the exact same key, ABC123, to decrypt it back into the original message, "Hello World." The key feature here is that the same key is used for both encryption and decryption. Now let's examine asymmetric encryption with the same message, "Hello World." In this case, we use a public key, let's call it pub789, to encrypt the message. This transforms "Hello World" into ciphertext that looks like Y9#NP4 at sign QM8. To decrypt this message, we need a different key called the private key, which we'll call PRV456. Using this private key, the ciphertext is decrypted back into the original message, "Hello World." The crucial difference here is that we use two separate keys. One public key for encryption that anyone can use, and one private key for decryption that only the intended recipient possesses. There are several widely used encryption algorithms that implement these encryption methods. For symmetric encryption, the most common algorithms are AES, which stands for Advanced Encryption Standard, DES or Data Encryption Standard, and Triple DES, which is an enhanced version of DES. For asymmetric encryption, popular algorithms include RSA, named after its inventors Rivest, Shamir, and Adelman, ECC or elliptic curve cryptography, and DSA, the digital signature algorithm. Each of these algorithms has different strengths and is chosen based on the specific security requirements of the application. Encryption and decryption are used everywhere in our digital lives. Online banking systems use encryption to secure financial transactions and protect your account data from hackers. Messaging applications like WhatsApp and Signal use end-to-end encryption to ensure your private conversations remain confidential. When you visit websites that start with HTTPS, the S stands for secure, which means encryption is protecting the data transmitted between your browser and the website. Email security systems also use encryption to protect sensitive communications from being intercepted and read by unauthorized parties. These applications demonstrate how encryption is fundamental to maintaining privacy and security in the modern digital world.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.